Hello and welcome to the Makeup Lab for Unit 12, Pencil Electrolysis. Purpose: electrochemical reactions involve the production of an electric current from an oxidation-reduction reaction. The common dry cell battery uses these redox reactions to power electronic devices. Remember that oxidation involves the loss of electrons, whereas reduction involves the gain of electrons. At the site of oxidation, the anode, there is a positive charge, and at the site of reduction, the cathode, the charge becomes negative. Electrolysis is the process of using an electrical current to drive a non-spontaneous reaction. The result is typically the separation of ions. Using a pencil electrolysis device, a series of electrolytic reactions will be run and tested in various solutions. Description of setup: at each lab station you have a petri dish, pencil electrolysis device, a white sheet of paper or paper towel, and a graduated cylinder. Materials include three different solutions: MgSO4, Ki, and CuCl2. And these three solutions we're going to do electrolysis on and record observations seen. This white paper will be utilized to act as a background. We have here a solution of magnesium sulfate. And this solution of magnesium sulfate will be tested with this pencil electrolysis device, which has a 9-volt battery attached via a battery clip to two alligator clips. And those two alligator clips clipped on the pencil so that the teeth of the alligator clip, each one is biting into the lead of the pencil, which is carbon, graphite. Two sharpened pencil lead tips on each pencil there. We also have the red wire. The red wire indicates the anode. The other one, the black wire, that indicates the cathode. So, like the data, I'll hold the anode, the one attached to the red wire, on the left, and the cathode will be on the right to match the data table so we can better get our observations in there. So trial 1 here has us test the magnesium sulfate. So I'll put the both pencil leads into the solutions. Let's see what we got going. It looks as if we have bubbles forming on the cathode, fast bubbling. I see bubbles over on the anode as well, but the bubbling doesn't look quite as vigorous. Let's see if a zoom in helps at all. So there we can kind of see it. So it looks like fast bubbling on the cathode, slower bubbling on the anode. The second part of the procedure for magnesium sulfate has us add a dropper full of universal indicator. So we have our universal indicator, dropper full. We're just adding that mixture in there. Well, that looks pretty neat. The universal indicator's main color, as it comes from the stock solution, is green. Looks like we had a little yellow, some orange, but it looks like when it's all kind of settled out here, we're pretty red overall. Just spilled a little indicator. Now, to reperform that same test, pencil electrolysis device into the magnesium sulfate with universal indicator. I still see the bubbling over on the anode side and the bubbling on the cathode side, but it looks like over here on the side of the cathode, it looks like we have some blue coloration around the pencil over on this side. And it's just kind of swirling around, as you can see. From my perspective here, it looks bluish. A little less so within the video picture. So it looks like we have red, and it stays red over here. So we'll go with red. And then for the anode, and then for the cathode we have blue, it looks like, forming there. So for this, trial 1, under the universal indicator line, turns blue for cathode, turns red for anode. The next test utilizes the next solution, potassium iodide, cleaning off the pencil electrolysis electrode tips, pencil lead in other words. Move this solution out of the way. Looks like a little spilled. Bring in the potassium iodide. For this one, we're doing two tests on this. First, without the phenolphthalein indicator, and then with the phenolphthalein indicator. Cathode once again on the right side. I'm observing lots of bubbles here on the right side. Oh wow, and I got looks like some bubbling occurring on the left side, so anode bubbling, cathode bubbling. And we have, it looks like, a pink color over on the right side as well, and a brown color over on the left. The pink was unanticipated. There may have been phenolphthalein residue left over in this particular dish. So let's see what happens when we have the phenolphthalein added. So adding the phenolphthalein indicator. Getting a swirl here, actually stir it around. No longer colorless. Should still be able to see a difference. Putting the electrodes back in. So see strong bubbling on the cathode, small amount of bubbling on the anode. And I see the brownish color coming off of the anode on the left. I once again see that magenta pink color coming off of the cathode on the right. So this was the potassium iodide solution. It looks kind of nice with those colors. The third and final solution is copper chloride. Copper chloride, when it's in the Cu2+ form, as the copper is in solution, has a distinctive bluish color associated with it. So that's why you're seeing the blue. There's nothing to add to this one, so it's just a single test on the one solution. No indicator is going to go in. Cathode on the right, anode on the left. Putting this into the solution. I observe bubbles on the left. On the right side, do not see any bubbles. It does look like the lead is kind of getting a coating on it, a dark coating. I couldn't notice it right away, but now it seems to be building up. Definitely building up now as this reaction proceeds. It also looks as if we have some solid that came off of that pencil lead. Yes, definitely. We had a solid, dark, solid precipitate. Looks black coming off of that pencil lead. So we observed production of gas on the left side and then a solid forming on the right side. So gas on the anode, solid on the cathode. And that concludes the set of observations for the pencil electrolysis lab. Finish the results section and then turn your made-up lab in to your teacher. And that concludes us in our makeup today. Thank you.